Hello everyone, good morning. Let's wait for a second to join everybody. So this is our lesson objective. Recognize rotational and line symmetry in two-dimensional figure. So let's look at the next slides. How can you understand what is rotational symmetry and number of rotational symmetry, line symmetry and number of line symmetry. Let's look at
Yes,
Shadati.
sir.
Rishad, can you say what did you cover up to that and what did you learn?
So we learned about line of symmetry.
Hmm.
We saw how many lines of symmetry are there in the three triangles,
Hmm.
starting with equilateral, that is three,
Hmm.
and then isosceles that has one, and
Hmm.
scalene that has no line of symmetry. And
Good.
then we also saw some other basic shapes, for example, butterfly,
Hmm.
kite,
Hmm.
and then I don't know, some pentagon or hexagon was it?
Hexagon.
Hexagon. And then that's it.
Okay, thank you very much. So now I'm moving to the actually quadrilateral, that is four shapes. Just have a look. This is a parallelogram. Actually, this parallelogram, sometimes students became confused because why there is no line of symmetry. Most of the time, some students write there are two line of symmetry, but actually, you know, look at that. If I draw this one, have a look in this way or that way, I cannot fold it in two parts. Look, can I? No, I cannot make hold it in two parts which are identical. Even if I come on that side, still I cannot make it two identical parts. Even if I start with this side, or even if I move the shape, still in any way I cannot make to look at that. I'm trying in this way. Is it possible? It's looked like two shapes, but even if I come up to that, still some students confuse. Look, it doesn't mean two identical. I can draw a line over there, mirror line. Can you see actually?
Yes, sir.
Okay, so even if even if I stopped here, so still it's not identical. So same way if I go in the other way, so look, if I go in other way, look at that. Look, I can say okay, I made it half. Even if I say okay, I made it half, no, still you cannot say this is two identical shape. This may be two equal shape, but not identical. So that is the difference. So parallelogram is the best example to understand the line of symmetry. So any question for that? So I think all of you understand how the parallelogram is. Like I cannot make it to identical shape. I can move it in different ways. Still, I cannot make to identical shape. So that's why we say it has not that. As I showed one like parallelogram. Look, this is parallelogram. No line of symmetry, even no rotational symmetry. I'm coming later on. So just have a look. Line of symmetry square. We'll have four because I can draw four lines. These lines can make the square two identical parts. Rectangle, even only I can make two lines. I cannot join the diagonal. If I join the diagonal, look at that. If I join the diagonal, then it will not make two identical parts. It might make two equal parts. That means area of the two different shapes after dividing may be equal, but the shapes are not identical. So this is a symmetry is a properties of a like object. So if it is a properties of a object, so in rectangle I can make only two identical shape by using two straight lines, and rhombus same, only two. But kite I already described it before, one. And then another thing, sometimes students confused about the isosceles trapezium and trapezium. Trapezium have if I say just trapezium or trapezoid, whatever it is, so no line of symmetry. But if I say isosceles trapezium, that means isosceles means two sides are equal. So whenever a trapezium have two equal side, then it will have one line of symmetry. Remember, this is the actual confusion. If somebody said trapezium, it's drawn or not, so I will say only trapezium, then I will say no, it has no line of symmetry. But if someone said isosceles trapezium, then I will say one line of symmetry. But even in the exam, like even IGCSE or level wherever it is, if it is drawn an isosceles trapezium and then said how many line of symmetry, or even in some maths you need to use this one, then you will think, is it an isosceles trapezium? Then I can say one line of symmetry. If one area is given, other area will be, other part will be the same or identical. And now come to the rotational symmetry. So rotational symmetry, and I will say that it looks the same after the rotation. That means that time I said by a line, if I just rotate through a line or use a line to bisect it, make it two identical parts. And this time I'm saying if I rotate an object, specially rotate an object, then if the object is identical after a rotation, then I can say one rotation is done, so one rotational symmetry. If I can do two rotation, then I will say two. Whatever an object in front of you, after 360 rotation, it will come back to the same position. That means no changes. That is identical. So I can say after 360 rotation of any object, it will make an identical object. So I can say there is one rotational symmetry of every object. So scalar triangle, there is no line of symmetry, but still it has a one rotational symmetry. And sometimes another total rotational symmetry. Sometimes it is asked in the IGCSE question, even somewhere else I have seen, that is sometimes they ask a total rotational symmetry. If this is total rotational symmetry, then you have to think that they said how many line symmetry and how many rotational symmetry, add them together. That is the formula I have given over there. That is total rotational symmetry means number of axes of symmetry, that means number of line symmetry and order of rotational symmetry, add together. So remember this information. So sometimes students do mistake over there. So isosceles triangle, have a look. Isosceles triangle, if say line symmetry, isosceles is 1, rotational symmetry also 1, but total order of symmetry is 2. Equilateral triangle, rotational symmetry 3 and line symmetry is 3. This is total is 6. So this is the information is given for all of them. So you can see the video later on.